Hello everyone. We are starting chapter 3 with this video, and we're going to be working on section 3.1. So chapter 3 in general is on data description, and in this section we will be talking about measures of central tendency. Now you've heard of measures of central tendency before, I'm quite certain. What they mean by measures of central tendency are the mean, the median, and the mode. We're also going to talk about mid-range. May not be something you have heard of or heard of often, but that's a fourth measure of central tendency. And so when we talk about these, just in general, just to kind of give us a heads up, the mean is also known as the arithmetic average. That's where you add all the numbers up and divide by how many there are. You've probably been doing that since elementary school in some fashion. The median is the number that's in the middle, kind of like the median in the middle of the highway, and the mode is the most often. And then the mid-range has to do with the middle of the spread of the numbers. We're going to do all of these. I just wanted to kind of give you a little bit of a heads up. Okay, so let's start with a couple pieces of terminology. So there's two different terms in statistics that are often confused. There is parameter, which is a characteristic or measure obtained by using all the data values from a population. So if you have the data from an entire population, you could call that data, whether it's the mean, median, mode, standard deviation, whatever you're talking about. If it's from the entire population, we call that a parameter. And you probably are saying to yourself, I haven't heard of the term parameter very much as far as talking about data, and that's because we very often don't have the data from the entire population. More often, what we have is statistics, and the statistics are from a sample. So we take, remember, population is everything that you want to know about, but you can't necessarily get the data from you can't get every piece of data from the population. And so what we do is we take a representative sample and we look at the data from that sample and hope that it is similar in proportions and such to the population so that we can make some predictions about the population. And when we take that information from the sample, each of those is a statistic. And so we look at the statistics from that sample. And that's why you've heard of the term statistic a lot more than the term parameter, because it's much more common that we have to take a sample from this large population. So here's a couple of examples. So if you're talking about a parameter, it says if a business employed a dozen people and they calculated the average weekly sales of their employees, that would be a parameter because they're using all the data from the population of interest. So again, the reason they can call this a parameter is because it's all their employees. So average weekly sales of all their employees. So since they only have 12 employees, all 12 of them would be the population if they're talking about something about their employees. And so that's a parameter. And you can find parameters if the population is fairly small. And in this case, the population is only the 12 people that they employ. But if you were a business that had tens of thousands of employees, and calculated the average weekly sales of a sample of some of those employees, that would be a statistic. So if you do a sample, that's a statistic. And here again, because this is the whole population of those 12 people is all the people employed, then you can do all 12. But in this case, since you have tens of thousands of employees, think of something, huge, like all the employees of Walmart or all the employees of the federal government or something like that, where they have tens of thousands of employees. The federal government doesn't make sense for sales, but if you're taking those a sample from those employees and looking at it, then that's a statistic. The general rounding rule when we're calculating statistics or parameters is that we should really wait until the end of the calculations to round. And so what that means is leave the numbers in your calculator. So as you're calculating things on your calculator, and everybody should have a scientific calculator, which can be a regular scientific calculator like a TI-34, or you can have a graphing calculator. It doesn't really matter, as long as it's can do scientific calculator functions in order, it does the order of operations correctly and such. And so if you can leave the numbers in your calculator as you go along, don't clear it out, if you get 2.33333, don't clear that out and put in 2.33. Just leave it in the calculator and it'll handle it. Or I'll point out as we do things, if you can also use the answer button. And the answer button will take the calculation from the prior problem and put it into your current problem. So let's say you calculate something, you get an answer of 5.217, a whole bunch of digits, and you want to use that in your next problem. You would type in everything you want, and then when you get to the spot where you want that answer, you just hit the answer button, and it pulls the number from the last problem. We'll have several examples where we do that, but it's just more accurate, and that's the general rounding rule. It just says when calculating, it should be done at the end, so you don't get any more rounding errors than you have to. Okay, so measures of central tendency. The first term that we're going to talk about is the term average. But the term average is very ambiguous. Roughly speaking, it's a center of the data, or the most typical value. It's not what you have learned in the past is average. I always joke around and say, we teach you that, the math teachers teach you how to calculate average, and then later we change the name of it because we're mean math teachers. And that's what you used to know as the average. We're going to actually, it's called the arithmetic average, and we're going to now call it the mean. And we, mean math teachers changed the name on you. You already knew how to do something, and we made it think like you didn't know how to do it by changing the name of it. But in general, the word average just means the center of the data. It doesn't mean specifically add all the numbers up and divide them by how many there are. And then the measures of average are called the measures of central tendency, because averages find the center of the data. So there's 4 important measures of central tendency. There's the mean, which we talked about up here. That's where you add them all together. There's the median. There's the mode. And less common, the mid-range. Each measure has advantages, disadvantages, and sometimes it's useful to find more than one of them. Sometimes you find all of them. Sometimes you find a couple of them. Just kind of depends on the situation. So we're going to start with this mean or arithmetic average. So as I said, the mean, which is also called the arithmetic average, of a set of data is the sum of all the data values divided by the number of data values. And then we just have some kind of formal notation here. So if you're doing the sample, I'm going to bring this out over here. This is the symbol that we're going to use for the sample mean. And we're going to use it all through the book. So there's several variables that you're going to want to learn. I recommend that students write the variables down on like note cards and then kind of go through them like flashcards, because you really have to know what the variables are in order to use the formula sheet. So you can use the formula sheet on the exams, but the formula sheet uses the symbols, uses the variables. And so you got to know what the variables mean, or you don't know where to plug things in. So I always recommend that students do something like put this on one side of the card. I'll mention them as we go along. And then on the other side of the card, put sample mean. And then you can study the cards in any direction. You can read sample mean and try to remember what the variable is, or you could look at the variable side and say, okay, I have an X bar, which is how this is read, X with a bar over it, X bar. And X bar means sample mean. Okay, so if you make these cards, then you'll be able to use the formula sheet. It'll be useful to you. If you don't know what numbers to plug in where, the formula sheet is virtually useless to you. And so in order to find that sample mean, what we're going to do, it says here we have x1 plus x2 plus x3, and then so forth up to xn. So what does that mean? Well, this just means the first data value, the second data value, the third data value, all the way up until you get to the last data value. So x sub n is just the last data value. So let's say this is, you know, a class of 25's test scores. You would take the first person's test score, the second person's test score, the third person's, and you just add all of them up until you added all 25 of them together. And then the number underneath is n, because that would be how many there are. So you add them all up and divide by how many there are. And then an even more kind of formal way to write this is we use this symbol called, it's a Greek letter sigma, capital sigma, and we call that the sum of. So the sum of all the x's. Instead of saying x1, x2, x3, x4 and adding them up, we just say sum up all the x's. So for our test example, that would be like sum up all the values of the test scores. And then we still have n on the bottom. So sigma x is just an easier way to write x1 plus x2 plus x3. And then population mean, I won't go into this so much because these are identical, other than, I don't know where those L's are coming from. I think those L's might be a typo. I think they were supposed to be like dot, 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 like ellipses here, so that to be like continue. Yeah, I'm not sure why those are L's. But anyway, in this case, we have the exact same formula. It's just that we have a capital N on the bottom. And that's because N is the population, whereas little n is the sample. So big N is the whole population, little n is the sample. But other than that, the formula is the same. The only difference is, you'll notice we have a different symbol here. And so this would be your second card. When you see this symbol, that means population mean. So that would be another card you could put in your flashcards to study that this symbol means that. And this is read as mu. It's a Greek letter, and it's the Greek letter mu, lowercase m. And so in general, this is really important also because this will help you keep track of what's what. The Greek letters typically represent populations, and the English letters typically represent samples. So in this case, you notice they used an X. They used an English letter. I mean, more specifically, it's a Roman letter. So they used the English letter X, and that's for a sample mean. And then they changed that to the Greek letter mu, and that Greek letter is a population. So English letter, sample, Greek letter is typically the population. Whenever you see a Greek letter, that's typically a variable for the population. Whenever you see an English letter, that's typically a variable for the sample. There's a couple times where that's not true, but for the most part, that's a good general rule. And then it also says that when you're given a set of data or data, assume it's sample unless they say that it's the population. And then when calculating a mean, what you want to do is you want to round one more decimal place than is present in the raw data. So if you had the test scores and they were all whole numbers, when you calculated the average, you'd want to round to the tenths place. So if all the test values were, 92, 75, 81, and so on, and then you get to the end and you have this average, and say the average on your calculator comes out to be 85.41375. Well, you wouldn't keep all these digits. You would just say, okay, that's approximately 85.4. So because the original data was whole numbers, we'd go to the 10th spot with the average. Okay, now I didn't calculate anything here. I was just showing you how to round it. Okay, I'm just saying, say you had a whole bunch of test scores, and when you averaged them, you got this on your calculator. Okay, so you would take it to 1 decimal spot because these went to the whole number. All right. So now we're going to do an example of the mean. So it says here the system-wide sales in millions for U.S. franchises of a donut store over a 5-year period are these numbers. So this is the data that they're giving us. And then it said we're going to use this sample mean, or this sample mean formula to calculate the mean. So all of these are to the nearest whole number. So again, we're going to go to the nearest 10th. So since the data values are a whole number, which means they don't go into the decimal spot, the decimal would be at the end. And so since those are all just whole numbers, we're going to take our final answer to the 10th. How do we get that answer? Well, we're going to do the sample average, or the sample mean. And this is all these numbers added up. So take the sum of the x's. So the sum of the x's, remember this sigma means sum, so sum of those x's, and the x's are 221, 239, 262, 281, 318, so we add those all up, and once we add those all up, those sum up to 1,321, and then we're going to divide by 5, because there were 1, 2, 3, 4, 5 pieces of data values. And so we divide by 5, and that comes out, if you round it to 1 decimal place, to 264.2. So the mean sales per year is 264.2 million. Because it says up here it was in millions, so we can add that to our final answer. All right. The mean for group data, I'm actually going to come back to because it's a little bit harder. I'm going to do the median and the mode. Hopefully I don't forget to come back to it. Okay, so the median is, in a data set, is the halfway point. And so what we do is we sort the data from smallest to greatest. It actually could be from greatest to smallest too, as long as they're in order. And we call that the data array when we put them in order. Some people do. I just say it's putting them in order. So list them in order, and then you're going to find the middle number. So in this case, here's the data that they gave us originally. 95, 31, 28, 57, 83. Okay? So first thing we want to do is we want to sort that. So we're going to put 28 first because it's the smallest, then 31, then 57, then 83, then 95. And then we look for whatever number is in the middle. Well, since there's 5, I can put there's 2 numbers on the left, 2 numbers on the right, and there's a clear middle number. And so since 57 is right in the middle, then 57 is the median. Okay? But sometimes, I mean, about half of the time, we get a set of numbers that has an even number of values in it. So we get a set of data, in this case, that has 6 numbers in it. Well, we can't, when we put 2 on one side and 2 on the other side, so we put these in order, 103, 117, 128, from smallest to biggest. When I do that, I can put 2 on each side, but that leaves 2 numbers in the middle, 128 and 135. So since those are both in the middle, we want to find what the average of those is. So the middle is like in between those 2 numbers. And so we're going to take 128 plus 135, and we're going to divide it by 2 to get the average. We're going to find what's halfway between 128 and 135. And so, sorry, this should have been summed up. So 128 plus 135 is 163. I'm sorry, 263. And we divide that by 2, and we get 131.5. And this is when you can see it didn't come out to be a whole number, and we round it to 1 decimal spot if necessary. Same rule as with the mean. Okay, so the last of the 3 first basic ones is the mode. And the mode we can remember by it is the most. Oh, I know. I wanted to say something about median first. If you're trying to remember, which is which, we already talked about that the mean is just what you used to know as the average, although average means a little bit more than that, but it's what you've always known as the average. But the mean math teachers changed the name. So the mean is just what you've always known as the average. Add them all up and divide. The median, if you're trying to remember that, think of what you have in a highway. Okay, so you have, one side of the road that goes like this. You have the other side of the road that goes like this. We're thinking about like an interstate. And in between them, you have the median. So the median is that middle area between 2 roads. Well, the median in statistics is the middle of the numbers. So median is middle. Okay, and then the last one that of the 3 kind of major ones is mode. And mode, a lot of people will remember because they both start with MO. Mode means what happens the most. The mode is the most. So in this case, the problem with this definition is sometimes a value can occur more than the others. One single value can occur more than the others. That's called unimodal. Uni as in one, like a unicycle. Sometimes we have 2 values that occur the same amount as each other, but more than all the others. That would be called bimodal, and you'd have 2 modes. You'd list both of those. You would say the mode is 5 and 7. You'd say both of them. Sometimes there's even more than 2. We call that multimodal. And sometimes you have every data value that occurs once. This says if no data value occurs more than once, the data set has no mode. I'm going to even change that a little bit. If no data value occurs more than the others, because you could have all of them occurring twice. So let's say you had a set of ages in a preschool class. So you have 2 2-year-olds, 2 3-year-olds, 2 4-year-olds, 2 5-year-olds. There's no mode there. Nothing occurs more than the others. And we wouldn't say the mode was 2, 3, 4, and 5 when none of those occurs more than the others. So if they all occur the same amount, so here there would be no mode. If we had, let's say we had 2, 2, 3, 3, 3, 4, 4, 5, 5, then the mode would be equal to 3 because it occurs more than the others. Let's say we had 2, 2, 3, 3, 3, 4, 4, 4, 5, and 5, then the mode would be 3 and 4 because 3 occurs more than the others, but 4 occurs the same amount. So you can have no mode, you can have a single mode, you can have bimodal, and then you could have multimodal. And then if we're looking at group data, you can also have a modal class, and that's the class that has the highest frequency. We'll do one of those here in a bit, and you can see that. Actually, I'm not sure if there is an example of that. So the modal class would be, let's say you had some data. And let's say you had, 20 to 24, 25 to 29, 30 to 35, 34, and then 35 to 39. And let's say this class occurred, the frequency was 5, this one was 12, this one was 7, and this one was 2. Then in this case, because that class occurs the most often, has the highest frequency. So the modal class for this data would be 25 to 29. Not the 12. The 12 indicates that it's with the modal class, but the modal class is the class, the 25 to 29. All right, I think we're ready to go back to that one that I skipped. Oh no, we have some examples of mode. All right, so the examples for mode, in this data set, it says we've got 15, 13, 19, 21, 19, 14, 23. Now you don't have to sort the data in order for mode, but sometimes it's easier to see it if you do. So in this case, went ahead and did that. If we sort it 13, 14, 15, 19, 19, 21, 23, we can see that everything occurs once except for 19. And so since 19 occurs twice, the mode is 19. In this set, they were nice enough to already sort it for us. So 54, 54, 54, 57, 57, and so on up to 79. In this case, we have 4 61s. 54 is only 3 times, 57 only twice, 63 3 times, but then we've got 68 also occurring 4 times. And then 72, 72, 76, 79. So in this case, 61 and 68 both occur 4 times. And so the mode is 61 and 68. We don't say the modes are. It's kind of weird terminology. Typically, they'll say the mode is 61 and 68. All right. And then in this case, everything just occurs once, so there is no mode. We just have 34, 38, 51, 79, 104. Nothing repeated, nothing occurring more than the others, so we would say no mode. And we want to say no mode. Don't say zero mode. Zero mode would be if you had a list of numbers and zero, list of values, and 0 occurred the most out of all those numbers. So we don't want to say it's 0. We want to say there's no mode. There's no number that occurs more often than the others. Saying the mode is 0 means there's literally data values that are 0 and those occurred the most. So like let's say on this data set we added 5 more data values. Let's say it was 0, 0, 0, 0, 0, so on. Let's say it was an 80-point quiz and there were 5 people who missed the quiz. There were 3 people that got a 54, 2 people that got a 57, and so on. Well, in this case, if we add those zeros in there, that would make the mode, because they got zeros on their quiz by missing it, the mode is 0. That was the most often occurring grade. So if we want to be careful when there's no number that occurs more often that we call it no mode, not 0 mode. Okay, so now let's go back to that one that I skipped, and we'll talk about the mean for group data. So the next thing that we're going to learn is we're going to learn how to do the mean for group data. So let's say instead of having all the raw data, all that you're given is the classes and how often that occurred. Well, what this means is that somewhere between 15.5 and 20.5, or realistically from it could be 16, 17, 18, 19, or 20, we know there's 13 data values. The problem is we don't know which of those they are. We don't know how many 16s there are, how many 17s, how many 18s, how many 19s, how many 20s. Because remember, if boundaries are 15.5 to 20.5, that means that the class was from 16 to 20. Okay? But we don't know out of these 13 how many were 16, how many were 17, how many were 18. Same thing with this next one. This next one would be the values from 21 to 25. We know there's 6 of them, but we don't know which ones they are. We don't know if it's 6 21s or a 21, 2 22s, 1 23, 2 24s, and a 25. We don't know how many of each there are. So what we do is we assume, because we don't know exactly which one it is, we assume that the values are all right in the middle. So we're going to take 15.5 plus 20.5 and divide that by 2, and that gets us 36 divided by 2, which is 18. And so we assume that there are 13 18s. So I'm going to write that out. It's a little tedious, but I think it helps understand this process a little bit better. Sorry there was that little glitch there. The ice cream truck drove by and made my dog bark. I didn't want my dog barking on the recording and scaring anybody. So we have 13 18s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we assume that there's 13 18s. And then we're going to do that for the next class. So the next class, if we average 20.5 to 25.5, the average of that is 23. So if we add those together, we get 46. Divide that by 2, the midpoint is 23. So we assume that there are 6 23s. So 1, 2, 3, whoops, sorry. I wrote the 6's instead of the 23s. So 1, 2, 3, 4, 5, 6 23s. When we find the midpoint of 25.5 to 30.5, add those together, we get 56, and divide that by 2, we get 28, and we assume that there are 4 28s. And then here, the frequency is only 1, so we assume that there's 133. That's the midpoint for 30.5 to 35.5. And then there's 138. And again, we're not certain of this. We don't know that there were 13 18s. There could have been a 17, a 16, a 16, a 17, a 19. But we just use 18 because we don't know what they were. And so if we pick the number in the middle, we're hoping that our ones, when 18 is too high, it'll balance out for the times that 18 is too low for the actual data values. And so then we add these all up. So if we add these all up, the sum of these x's is 555. So if we take 18 plus 18 plus 18 plus 18 plus 18 all the way plus 23 plus 23 plus 23 plus 23 plus 23 and so on, and add those all up, we get 555. And then there were 25 data values. So the frequency is 25. And so we take that, we take the sum of the x's, and we divide by 25. And we get 22.2 million. And I know now you're saying, man, that is a lot of numbers that we have to write out. It seems like a long process. Isn't there an easier way? And the answer is yes, there is an easier way. I don't have to write 18 out. We don't have to write that out 13 times in order to figure out and add them up 13 times to calculate that. We know what multiplication means. We know that if there's 13 18s, that we can just take 13 times 18 and get the number. So these together add up to 234. So instead of writing them all out like that, I can just, from my table, I can say, okay, well, the frequency was 13. I'm going to assume they're all 18s. 13 times 18 gets me 234. And you do that for all of them. So there's 6 23s, and that adds up to 138, because 6 times 23 is 138. And then we keep doing that. 4 28s would make 112. 138 is, or 33 is 33, and 138 is 38. And then instead of having to add up all 25 numbers, we just have to do 5 multiplications and add 5 numbers. It's a quicker way. We should still get 555. And so you take the frequency times the midpoint, f times x sub m, frequency times midpoint, and we get these numbers, these multiplied numbers, these products, and then once we have all these products, we add those up, and that's the same as if we had added up all 25 numbers individually. And then the average of this is 22.2 million, which makes sense. This number should make sense. If you look up here, we had numbers that were from 16 to 40, and we got an average of 22. And it makes sense that it's kind of more in this area because almost all of the data values were in those first two classes. We had 19 data values in the first two classes, 13 and 6, and then only 6 that were after that. So it makes sense that the mean came out to be, in this area. So that's a grouped data mean. You'll be only given these first two columns. You'll have to find the midpoints. Once you find the midpoints, multiply the frequency times the midpoints, add that all up, and then divide by the total of the frequencies. Okay, so now we're ready to go back to our past the ones that we've done, and do our last, which again is the least common, but it is a measure of central tendency. It's called the midrange. Now the midrange is pretty quick to calculate because when you're looking at the midrange or determining the midrange, we only care about the smallest number and the largest number. The midrange and the median sometimes get mixed up with each other. But the median, we look at all the numbers and we find which one is in the middle. The mid-range, we really only care that this data went from 54 to 79, and we're trying to find what's right in the middle. We don't care about any of the other numbers in between them, only that it starts at 54 and it goes to 79. And so how do you find the middle of two numbers? You average them. So the mid-range, the range is from 54 to 79. Well, technically not. The range is technically 79 minus 54. But in everyday language, we would say the numbers range from 54 to 79. And if we average those together, that comes out to be 133. And we divide that by 2, and we get our 66.5. And so this number right in the middle of the values 54 and 79 is 66.5. Now you can see that when we did these, if you look at all of these different calculations, the mid-range was 66.5. That's right in between the highest and the lowest number. We already mentioned that the mode, we already used this data set, and the mode was, remember, 61 and 68 because they both occurred. So mid-range is 66.5, mode is 61 and 68. If we calculated the median, that would be the number right in the middle. So that would be, here's 10 and here's the other 10, if I cut that right in the middle. So 61, 63, and then 63, 63. So we fall right in between two of the 63s, so the median is 63. And then the mean, if we added all these numbers up, gosh, they did that again with the ... so this should be ... and those total up to 1,280, divide that by 20 because there's 20 numbers, and the mean is 64. So you see, sometimes they come out fairly close. These are all fairly close to each other, but none of them are the same. We have a different mid-range, then mode, then median, then mean. Everything has got a different value. But mostly, I want you to note that the median and the mid-range are not the same. Okay, some people, again, will get the median and the mid-range mixed up because they both very much sound like middle. But the mid-range is find the range of the numbers, 54 to 79, and then find right in the middle of that. The median, you have to list out all of the numbers and find where the middle is. So the next thing we're going to talk about is a weighted mean. A weighted mean will probably feel kind of similar to what we did with the mean of a group frequency table. It's a little bit, it's a different calculation, but it feels kind of similar in the process. So what we do with the weighted mean, this is like when you have values that are not all the same amount. They're not worth all the same amount. So, for instance, in classes, sometimes your teacher will say, you know, your homework is worth 20% of your grade. Each of your exams is 30% of your grade. This class we have a weighted average for the grade, but it's not a very good example because everything's worth 20%. So we have if you're in one of my regular semester classes, it's 20% for the first test, 20% for the second test, 20% for the third test, 20% for homework, 20% for the final. So they're really all weighted the same, so it's not a great example. But we're going to use a grade point average as an example here in the next one. But what we do when we have a weighted mean is we take the weight times the value. So let's say, again, your teacher said, oh, your first exam is worth 20%. You would take 20% times your first exam grade. And then let's say your homework was 30%. You would take 30% times your second test grade, and so on. So we take the sum of the weights times the x's. I'll say values, so the data values. And then we divide that by the sum of the weights. Now, when we're talking about a grade, the weights total up to 1, to 100%. So oftentimes for grades, the weight sums up to 1. But other times it doesn't. Okay? Now, I really like to use GPA as an example for a weighted mean. And part of that is because I just really feel that it's important as a student that you understand where your grade point average comes from. And so it's a great example, and so I always like to use that. Not only here in the notes, but also on the exam. So I can guarantee you, again, I'm not going to lie to you, there will be a GPA problem on the next exam. I will give you a weighted mean, and it will be to calculate a GPA. Okay? So in this case, we have 5 classes that this student is taking. They're taking a class called Sports Analysis, they're taking a Statistics class, an Entrepreneurship class, Crowdfunding, and Social Marketing. So it looks like there's some type of a business major. And so they've received their grades at the end of the semester, and in the first 2 classes they got an A, the second 2 classes they got a C, and in the 5th class they got a B. Now, the typical scoring for grades in our system is that an A is worth 4, a B is worth 3, a C is worth 2, a D is worth 1, and an F is worth 0. Sometimes, at some schools, a D is also worth 0, but on our campus and at most campuses, a D is 1. And so when somebody says, I have a 4.0 grade average, that means they have an A average. And so we take these grades and we convert them to their number values. So these 2 A's become 4s, the 2 C's become 2s, and the B becomes 3. Okay, so the A's become 4s, the C's become 2s, and the B becomes 3. Okay, I'm going to get rid of those just so they're not in the way. Okay, and then what we do is we look at the hours. So in this case, the Sports Analysis class is only worth 2 credit hours, but the Statistics class is worth 4 credit hours, as is the Entrepreneurship class and the Social Marketing class. And then the Crowdfunding class is 2 hours again. So what that means is, for the Sports Analysis class, they got an A for both of those hours. So it's as if they got an A and then another A. Same thing with the Statistics class. So this would be for the Sports Analysis class. Okay, now we go on to the next class. They got an A in this class, but it's worth 4 hours. So 4 a grade of 4, but it's for 4 hours. If you're recently out of high school, might be a little confusing because in high school, almost all your classes are worth 1 semester. So if you take a class for a semester, it's 1 semester. And that's just not the case in college. You have classes that are worth more than others. Particularly, like science classes are usually worth 4, sometimes 5. Like a calculus class is worth 4. Our class is worth 3, so on. Okay, so then the next couple of classes they got a C on. One of them was worth 4, so that's like getting 4 2s. They got a 2 for all 4 of their hours, and then they got a 2 for 2 more hours, so that's the crowdfunding. Remember, this is the sports analysis class. This is the stats class. This is the entrepreneurship class. This one right here would be the crowdfunding class. And then finally, they got a B for 4 hours for their social marketing class. And so if we were to add all these up, that would give you the total points that they have. So 4 plus 4 for the first class, and then 4 plus 4 plus 4 plus 4 for the second class. If we added those up, those would total 48. But again, we don't want to do all of this because we know how to multiply. And so instead of doing 4 plus 4 plus 4 plus 4 plus 4, we're just going to take these numbers and we're going to multiply. And so we're going to take 4 times 2, and that gives us 8 hours. So 4 plus 4 is 8. In this class, the statistics, you get a grade of 4 for 4 hours, which gives you 16 points. So these are the points that you've earned for the semester, for that class. Now, that's the maximum amount you could have earned for those 2 classes. But for these C's, you could have earned 4s, but you only earned 2s. So even though this is a 4-hour class, just like this was a 4-hour class, you'll notice for this one, 2 times 4 only got the student 8 points. And so even though they took a 4-credit-hour class, they only got 8 points for that class, whereas before for a 4-credit-hour class, they got 16 because they got an A in it. Okay, so that matters is, again, for your GPA. All right, so the next thing we've got 2 for the grade, C, and we have that for 2 hours, and so they got a maximum, or they got 4 total points. And then the B 4 times got 12 points. If we add those all up, we get a total of 48. And then we want to divide that by the number of credit hours that you had for that semester. Or if you're doing your entire college career, you would do this for all your classes and then divide it by all your credit hours that you had taken. So in this case, the sum of the weights times the x's, so the points times the weights, so that's the hours, in this case 4 times 2, the weights times the frequency times the weights. So points is the frequency times the weights, 4 times 4. If we add those all up, the sum of the weights times their x's, so these two numbers multiply together, and then divide by the sum of the weights. And the weights in this case, the hours are the weights, and the frequency is the points. Okay, and so we take the 48 divided by 15, and this student got a 3.2 GPA for this semester. Again, if that went out more than 1 decimal point, you would still round it to 1 decimal point because the rounding rule says if it's whole numbers, when we divide, you round it to 1 decimal place. Now this one does come out to be exactly 3.2. Also, colleges are confusing on that because even though they do this way, they'll usually put your GPA on your transcript out to 2 decimal points. So statistically speaking, they should only go to 1 decimal point, but they almost always go to 2 decimal points. And again, this will absolutely, definitely, I'm not fooling you, not lying to you, there will be one of these on the exam. So it's a good thing to practice and make sure that you know how to do. All right. And then to finish up this section, we're going to talk about the benefits of each of the measures of central tendency. So for mean, some of the benefits is you use all the values when you're talking about the mean. It also varies less than the median or the mode when you take samples from the same population. So if you took a sample, 100 students from one high school, and then you went back to that same high school and you took another sample of 100 students, the mean tends to vary less from sample to sample. The median and the mode can kind of shift depending on if you get a low value or a high value. Also, the mean is used to compute other statistics, such as the variance, which we're going to do in the next section. So you need it for some other things. And another thing that's kind of interesting about the mean is sometimes the mean for the data set is unique. It's not necessarily one of the data values. So you could have, like those quiz scores, if you have a whole bunch of quiz scores and they're all whole numbers, you could have an average that's a decimal. Well, that wasn't even a possible score that somebody could get, but it was the average. It's one that I always like to throw out there is, there's data for like how many kids does the average family have, and it's like 1.2 or something like that. Well, if the average family has 1.2 kids, obviously no family has 1.2 kids if we're only counting born children. But the average is 1.2. Okay, and then the last thing, I actually misspoke up here when I said it varies less than the median and mode, and I said if it had high or low values. The reason it varies less than median or mode is that mode, you could have mode and median. It's not if you just have a high value or a low value would change the median and the mode. The median and the mode are just very dependent on how the data falls, kind of what's in the middle of it, and so those can really change with different samples. The mean actually is affected quite a bit by the highest scores and the lowest scores, especially if you get an extremely high or an extremely low value. These are called outliers, and we'll talk about those later. We'll learn how to calculate or figure out when there is an outlier. And then properties of median, mode, and mid-range. Median is used to find the center or the middle. It's very useful when you want to find out what's in the upper half versus what's in the lower half. So like if you were in the top half of the class or the bottom half of the class on grades, or if a child's height falls in the top half or the lower half of the distribution. The other thing about median is you can use it for open-ended distributions. So if you have a category that's like, think about like salaries, a lot of times they'll say, you've got people with a yearly income of 0 to 20,000, and then your next group is 21,000 to 40,000 or something like that. Then at the end, you might have something that says 200,000 plus, because there's a few people that fall up there, but they're very spread out. You can use the median in this case as long as you know how many are up here. You can still count, 1, 2, 3 on this side, and then 1, 2, 3 until you get to where the middle is. You can still find the middle even if the last category or the first category is that much or more or this much or less. So it's nice to be able to use the median. You'll notice when they talk about incomes, they often will use the median income instead of the average income because it's more representative, because you have these few people that are up here with the really high incomes, and it would skew the data. And so we want to, we often use the median for incomes. And then that it's also affected less by the outliers. The mode is kind of a most typical case. It's really easy to compute. You just got to look through the data, organize it and find what occurs the most. It's nice because it can also be calculated for nominal or categorical data. So you could say, I have a sample of people's hair color and I got brown hair the most. So brown is the mode, which is kind of sounds weird, but it can be. You just, whatever happens the most often is the mode, and the mode could be a category. One of the problems with the mode though is it's not necessarily unique. You could have a mode, as we said, where there's one mode, instead of one mode, there's two modes or three modes. There could be no mode. So the mode's kind of flaky in that regard. And then the mid-range is very easy to compute, but it only uses the highest and lowest values. It doesn't care anything about what's in between. And it's also strongly affected by outliers because it's the highest and the lowest. If you have an outlier, then you get a big effect on where the mid-range is at. And now to finish up our first section from chapter 3, we're going to talk about distribution shapes, which we've talked about a little bit already. We have right-skewed data, and if you remember, when data is right-skewed, that means that the tail is on the right. Okay, so in this case, think of this as the body of the data set or the body of the animal, and it's tailing off to the right. So this is right-skewed. Then we have, and when that happens, we didn't talk about this before, as a result, the mean will be larger. So what happens is this tail, so the tail pulls the mean up above the median. And actually the mode is then below. So in this case, the mean gets pulled up above the median in the mode, and the mode would actually be the lowest value. Okay, if it's symmetric data, then we have it, fairly evenly distributed. It doesn't have to necessarily be a perfect bell curve as long as it's kind of the same on both sides. When that's the case, then you have your mean, median, and mode all pretty much in the same area. The middle, the arithmetic average, and the most often are all occurring kind of together. So if you have a symmetric data set, the mean, median, and mode are often are going to be very close to each other. And then if you have left-skewed data, where it tails off to the right or to the left, then as you would expect, it's going to be the opposite up here. In this case, the tail pulls the mean down. So if you think of this as, say, those incomes that we were talking about, those very few super high income people would pull the average. So here's everybody, most people have incomes in this area, but then you get these people up here, a few people that have really high incomes, and that would pull the average income up, which is why we often use the median instead. Think of this left-skewed, you could think of that like test scores. Let's say you had a class where almost everybody in class did well, but you had a few people that didn't do very well. Well, that would pull the average for the class down. So that tailing off to the left, those few low scores that aren't really indicative of the rest of the data, pull the mean down. They pull the average, the arithmetic average down. And so in this case, it might be more proper or more helpful to say, well, the median of the class was here, or the mode of the class, most students scored in here, rather than saying, what the average is. So right-skewed pulls the average up, pulls the mean up, and left-skewed pulls the mean down. And that's it for section 3.1. I'll see you back for section 3.2.